Hi guys, welcome to section C. We're going to finish up chapter 19 today. We're going to talk about clouds and precipitation, okay? So let's talk about how clouds form. So remember, as part of the water cycle, we've got, the surface water, whether it's from lakes or rivers or the ocean or whatnot, that water vapor is heading up, okay? So water in its gaseous form is called water vapor, okay? And it's warmer down on the surface, and that's why there's more evaporation that happens, okay? As that water vapor rises, the air cools down, and that allows that water vapor to recondense back into liquid water, okay? The dew point we talked about a little bit earlier in this chapter, that's the temperature at which 100% relative humidity is reached within the air. And that temperature, depends on where you are in the atmosphere, okay? So as the water vapor is going up, the temperature is going down, so it's able to reach that dew point a little bit easier, okay? A cloud, probably never thought of this definition, but it's a huge mass of tiny, tiny, tiny little tiny liquid droplets of water, okay? And again, as that warm air rises, that water vapor cools and those particles get closer together and it actually condenses into liquid water. If you can see it, it's liquid. Same with steam. Steam above a pot of water is liquid water, okay? Water vapor is invisible, right? To help with this condensation, clouds can form easier if there's something known as a condensation nuclei, and it's basically just a microscopic piece of something in the atmosphere. It might be a piece of dust, it might be a piece of like smoke soot, something that gives the water vapor a place to collect, okay? And you've noticed this, you can go up to a window and fog it up even though it's warm outside, okay? So the water vapor that comes out when you exhale, you can't see it unless it's really cold, then it's liquid water. But if you do that on glass, the liquid condenses together, it gathers together, okay? And so kind of the same principle is happening up in the atmosphere. These little tiny particles are where the particles of water can start collecting, and then it helps them condense. This can also happen in really, really cold temperatures, and these are called freezing nuclei. So even higher up, where it's even colder, where if the dew point is, or if the temperature is below freezing, not necessarily below freezing of water, but if the temperature is enough below the dew point temperature, then that water vapor can turn directly into ice crystals. It doesn't even turn into liquid first. And that's called deposition. We'll talk about that a little bit on this slide. I don't know if you've taken time to notice this, but when there's clouds in the skies, they don't always look the same. There's lots of different types of clouds, okay? Clouds are named by their shape, partly, okay? And the main kind of root words that we use for the shape of the clouds is stratus, cumulus, and cirrus. The stratus clouds, that's when it's like kind of hazy and kind of totally gray outside. You can't really even make out distinct clouds. It's kind of like a sheet-like layer of clouds. That's stratus clouds. Cumulus clouds, those are the cartoon clouds that you draw. Those are the fluffy white clouds that look like giant pieces of cotton, okay? But then there's also cirrus clouds, and those are really thin and wispy. It almost looks like God took a paintbrush up in the sky. Those are very, very thin and like there's like paintbrush strokes that made them. Those are actually made of ice. Those are high up. And so again, if you can see it, it's not water vapor, but it might be ice. Mostly it's liquid. Right. Clouds are also named on their altitude, how high up they are. So we see like prefixes or suffixes, some of them are different, strato, alto, and cirro. And if you look at page 466 in your book, you can see a bunch of the different combinations of these different clouds, okay? The strato clouds are low, so between 0.8 and 2 kilometers. The alto clouds, and you can have alto cumulus, you could have alto stratus, you could have alto cirrus. Those are the kind of medium level clouds. That's between 2 and 6 kilometers up. And then finally, we have the cirro clouds, cirrostratus. I don't know if there's a mix of cirro and cirrus. That'd be weird. Cirrus? I'm not sure if that exists. Anyway, the cirro clouds are the really high up ones. 6 to 12 kilometers, okay? There's also nimbus or nimbo that's used sometimes. We'll talk more about cumulonimbus clouds when we talk about severe weather. Those are storm clouds. Those are the big, fluffy, kind of grayish ones that hold a lot of precipitation in them, okay? Fog is a cloud. It's just a cloud that's on the ground. So if you're driving around outside and it's really, really foggy outside, you're actually driving through a cloud. Fun fact. All right, so speaking of precipitation, we've talked about precipitation before. Let's talk about it again. We talked about it when we talked about that water cycle. Basically, precipitation is when water falls back to the earth, and that could be liquid water or it could be frozen water. The most common type of precipitation is rain, okay? A typical raindrop is between 2 and 5 millimeters, okay? So here is a ruler. A centimeter is divided up into 10 millimeters, okay? So a typical raindrop is anywhere between 2 and 5 millimeters. Sometimes it's just misting outside. We call it like drizzle. That's half of one of these, half of a millimeter, okay? Now, if you look on page 468, it talks about the size of droplets. A typical droplet of water in the cloud is 2/100ths of a millimeter. So if you take one of these, not a whole centimeter, but just one of those little pieces, and you divide that into 100 more little sections, 2 of those would be how big a droplet of a cloud is. That's why they don't fall. They're too light. But as they collect, okay, this thing called coalescence happens, and as the droplets move down, they collect more. But this is even happening within the clouds. The water will pull other droplets together, and pretty soon it gets heavy enough that it falls. Okay, so again, rain is one of the most common types of precipitation. We also have freezing rain. And that's liquid water. It falls as rain, but then the surface is cold enough that it freezes on contact, okay? That's freezing rain. There's sleet, which is rain for a while, but then it freezes on the way down, okay? And so it's similar to hail, but it's more like a frozen raindrop. Hail, and I'll get back to snow. Hail is something that is frozen up in the clouds, and it is built up by these things called updrafts. So you've got these big, huge cumulonimbus clouds, and there's wind that blows straight up. So a little piece of hail, a little piece of ice might start falling, or even a raindrop might start falling. But that updraft blows it back up into the cloud where it's colder, freezes, starts falling, updraft blows it back up. And so it's like layer after layer after layer of ice is forming in these hailstones until finally they're too big and heavy for that updraft to keep them up in the air, okay? So you can imagine the type of wind that must have been in the clouds that allowed something that big to form. Typically, they're like, BB size or pea size pieces of hail, okay? And the last one is snow, and snow is different. It's frozen, but it's real airy and flaky, okay? This is an actual microscopic image of a snowflake. Snowflakes are 6-sided, and they are always different from each other, and they're beautiful. I think the microscopic views of snow are really, really fascinating. And that is precipitation. But we also get water that can kind of collect on the surface of the earth. And so we get, water vapor that can turn into liquid on the surface. That's known as dew, okay? So if it's cold enough, there's water vapor around us all the time. If it gets cold enough, it's below that dew point, then the water will condense. That's in the mornings right now, you go out in the grass and the grass is wet. That is dew, okay? That's because in the morning, the temperature is below that dew point, which means the air cannot hold as much water vapor. And so the water vapor turns back into liquid water, okay? The warmer the temperature gets, the more water vapor the air can hang on to. Okay. Now, if it gets really cold, and we only get this a couple times a year where we live, you might see frost, and you might see it on your cars. You might see it on the grass. You might see it on the roofs of houses. When it's cold enough, when the temperature is far enough below that dew point, Kind of like the clouds, the water vapor skips that liquid phase and goes directly into the ice, the solid phase. And that, again, is known as deposition. And we call that frost. And I believe that's all. Bye-bye.